stadium. That's the first time for me. I've been appearing on the movie theaters, on the regular theaters, and on a different kind of places, but it's the first time on the stadium, and I'm very happy about that. And if someone could take a photo and share it on Twitter, I would be very happy for this photo. I'm not sure if there is a normal photographer in here who could take me a nice photo. Oh, and thank you. So the third thing is that it's good to have some nice questions, and I will ask for them in the end if we have time. If not, then come to me and ask them to me. So it might be worth that. Okay, so I think we can start. Hello everyone, welcome to Kotlin Coroutines in practice. In this presentation, I would like to show you. Change the adapter. I will start again, no worries. So, welcome to Kotlin Coroutines in practice. In this presentation, I would like to have a very short section about what are coroutines so that we are all on the same page. A big section about common use cases. I cannot go into details, but I hope that for those who use coroutines, it will be eye-opening for good practices. For those who not, I will show some possibilities. And a very short section about testing coroutines in the end. So this presentation is based on my book, Kotlin Coroutines. I do not have it here because it's not printed. You can order it on KDP, on Amazon, so you can have a printed version, but I haven't printed it myself, so I do not have books to give away. I only have effective Kotlin with me, but the book is fully published, released, and I have a really nice opinions about it. You can treat this presentation as a summary of this book. Okay, so let's start with what are coroutines, not only in Kotlin, but in general, what are coroutines? Do you have any ideas? Speak up? No? So, if you take a look at just an arbitrary code like this one, not much can be said from this short snippet, but one thing is for sure. You can only start it from the beginning, and then it will be running until it's finished. Okay? If you want to stop it, you need to keep some thread that is staying and being alive. So one process in a regular programming goes from the beginning until the end. It cannot be saved in the middle. The coroutine, by definition, is a part of our code that can be suspended. And suspension is like saving a game. See? So suspension, when you suspend the function, you are receiving an object, a continuation, that has all the local state, and that's all that is left. You do not need to keep any thread active, you do not need to keep anything else active. You can then resume it, what means jumping in the middle of function and continuing from this point. I really like a gaming analogy. So you can imagine that your threads are like those game machines. And the classic programming is like those classic arcade game machines where you could not stop, you could not save your game. See, if you needed to go to eat dinner, you needed to pause it, and the machine needed to stay active. If you needed to have sleep, you needed to pause it, and the machine needed to stay active. You could not move your state from one machine to another, and it was very limiting. Coroutines introduce into this gaming metaphor an idea of saving the game, what is so intuitive, but also so useful that you can, play one game, and whenever you want to stop it, you can save the game, go do other things. Whenever you want to go back, you take yourself, save, and continue from the point where you stopped. It introduces a lot of capabilities, so your resources are managed much more efficiently. You can on one computer, you can play multiple games interchangeably. And one game you can play on multiple computers interchangeably. You can just move your save from one computer to another. And that's a good metaphor of coroutine. Coroutine is an abstraction, a lightweight abstraction on top of threads. One thread can run on multiple coroutines. Multiple coroutines can run on a single thread. And this introduces a very, very powerful capabilities, not only for multi-threading, because there are also other use cases that can be implemented with coroutines, like sequence builders that could not be implemented before. By the way, coroutines are widely known in programming. The async await, the generators in Python, those are very limited, but those are coroutines because you can stop them at some point and resume them in the future. Of course, Kotlin introduced the general purpose coroutines, and it also introduced a lot of features like cancellation, exception handling. We'll touch a little bit of them during this presentation, so it's a very powerful implementation of coroutines, but this is the essential idea of coroutines. So for instance, you have two coroutines. You can run them both interchangeably on a single thread. A main thread is first doing things on one, then this coroutine is suspended when we wait for the response from our endpoint, and then we do other coroutine, we execute other coroutine. Then we wait until the data are back there. Once the data are ready, we jump in the middle of this function and we resume from this point. Suspending functions are not coroutines. Suspending functions are functions that can suspend a coroutine, okay? They still need some coroutines started. Suspended functions by default are synchronous. So if you have multiple suspended functions that you call, you first get the first one. Once the data are there, you get the next data. Once the data are there, you get the next one. Once the data are there, you can show news. However, with coroutines, we can easily introduce other features like async await. In Kotlin, that's just the regular functions built on top of suspension and coroutines. A big advantage of coroutines over libraries like Xebia is that you can implement practically all the patterns with a very simple construct. So you can use collection processing, you can use for loops. So here we have a pagination implemented in two ways, fetching all the pages at once and page by page. You know, it's intuitive and obvious. If I would want to do that with Xebia, it would require a lot of different functions. And that's the advantage of coroutines. Okay, so let's cover a typical use cases. I will target mainly Android and Backend. And I must start by saying that if you are lucky, thanks to the great support offered by the community, by libraries, in many projects to introduce coroutines, especially on backend, it is nearly enough to just introduce a suspend function here and there. This is thanks to a great support for libraries, like Retrofit, that understands suspend function, and when you use it, the suspend keyword, and when you use it, suspends coroutine instead of blocking a thread. Or a Spring Boot that when it can see a suspend modifier, it creates a coroutine for you. So we are hiding those, resuming the suspension and starting coroutines. It is hidden by the libraries. In some projects, all I needed to do to introduce simple coroutines was that. And then you can benefit for all the other features of coroutines we'll touch soon. However, first of all, there are special cases that we need to cover. Second of all, there are possibilities that were not before that we also need to cover. I separated this presentation into three parts. Data layers, so this is where we have our repositories, providers, adapters, data sources, etc. Domain layer, so this is where our business logic lives. And our presentation layer, so this is we have our controllers, presenters, view models. So let's start with the top, our repositories. Again, if you're lucky, it is enough to just use a suspend modifier here and there. From my experience, All the other cases when it's not enough are either of two categories. The first one is when you need to call a callback function. And this is a typical wrapping for a callback function. You can read it as follows. Sorry. You can read it as follows. You suspend the coroutine, but before you do that, you start a callback function. And in case of a success, you resume your coroutine. In case of an exception, you can resume it with exception, which means throwing an exception out of suspension point. It's not the only option. You can resume it with some failure or something else, but this is a popular option. And this stuff in here, you said that when a coroutine is cancelled, we have cancellation mechanism in Kotlin, you should also cancel the call. More about it in the chapter How Does Suspension Work in Kotlin Coroutines. It is also published for free in the chapter in the article on KT Academy. The second case is when you need to call a blocking call. And you should never call a blocking function on a coroutines when you do not specify a dispatcher, because you do not know what you block. And Kotlin coroutines very precisely manage the threads. So for instance, the default dispatcher uses as many threads as you have cores in your processor. What is perfect for CPU-intensive operations, but only if you never block threads, you know? Not to mention dispatcher's main that runs on the main thread and should never be blocked. So when you do not know what you block, you should not block. That should be clear. And so whenever you have a blocking call, we wrap it with context, dispatcher's IO. This creates a new coroutine, synchronized coroutine, so we are waiting for its result, but it's running on a different dispatcher. This is good when we are not blocking too often, because dispatcher IO has a limited number of threads in its pool. It's 64 by default. And it's not the problem that we will use all those threads. 64 is a lot, okay? The problem is that if you use dispatcher IO in different parts of your application, you do not know what they block, you know? So this part uses all the threads. You do not know what other parts do not have threads, see? So the point is that when your repository might be used quite often, we are making our own limit. Oh, this is described in the dispatchers chapter, also published on KT Academy for free. So to make your own limit, that's a strange syntax. You use dispatchers IO limited parallelism. But this makes an independent limit. So this is 5 limited to 5, but those 5 are not connected with those 64 from dispatcher IO, okay? And this is a safe way to do that. The next thing is that if you have parts that are definitely CPU intensive, it's better to wrap it with dispatcher's default. If it is already in dispatcher's default, no worries, the cost of that is very small. And also if you need something on the dispatcher's main and it's a suspending function, and you are not sure, and you do not want all your users of your API to be worried that they call it on the main thread, you can wrap it with the dispatcher's main immediate. Again, the cost will be small of redispatching. I mean, redispatching should not happen in this case. And and you are sure that from whatever dispatcher people call it, it will be called on a proper one. Okay, so let's move into a domain layer. Domain layer is where our business logic lives. This is where we could just use suspending function everywhere, and everything would be fine. So in here, I would say I do not know any cases where coroutines, when some special tricks are needed, like with this wrapping, blocking calls or callback functions. But this is where our coroutines can shine, because we can use coroutines to introduce concurrency here and there. So the simplest case is when you want to have async calls, you use async await. You also need to use this coroutine scope. This is a very important part. This needs to be there because it creates a scope. You might be wondering, why do we have it in here? On the end, it's not needed in JavaScript or in Python. It is because Kotlin has features that JavaScript or Python do not have. Cancellation, exception handling, etc. So for instance, imagine that those two requests are very expensive to calculate, yeah? And one of them has exception. So the question is, what should happen to the other one? And the answer is, the other one should be cancelled. Because, well, why calculating that if it's not needed anymore? So coroutine scope and the scope in general helps us manage our eliminate memory leaks, basically. But it also has its problems. Just imagine that you start multiple independent coroutines. Like here, for each action, I launch a task of sending notify to analytics. Okay? So if one of them has exception, if we use coroutine scope, it will cancel the others. So that's where you should use a supervisor scope. Supervisor is an alternative boss for a boss, and apparently does not care for its children. So when its children is dying, I don't care. So that's a good option if you have independent coroutines. Okay, the difference between this and this is small, and people often do not notice that, and then things are cancelled without their understanding why. So it's good to know what is coroutine scope, what is supervisor scope, and how cancellation works. More about that in the coroutine scope functions, also in the chapter published for free on KT Academy. A strange case, and case that you should know is, what if you have async calls and you would like to ignore exceptions in one of those calls, I hope it's clear that if a regular case would be the coroutine scope and use async await, it would be easy, and an exception in a single one would cancel the others, which is generally, expected, generally what we want to have. But in some cases, we using some APIs that are flappy, and we want to ignore those exceptions. Of course, the easiest solution is to wrap it in this function and silence the exception over there. But if you do not silence it in there, remember you need to use two mechanisms, because I've seen this mistake in a few projects already. One of them, of course, is that you need to use a supervisor scope so that an exception on one child does not cancel the others. But then when you call await, await returns whatever async returned. So if async throws an exception, await also throws an exception. So you should also wrap await with try catch. Okay, this is a tricky. This was a tricky part. That's why I wanted to say about that. And we have a timeout capability, not used often in coroutines. I don't see it often in production. However, it's quite cool. So it's just if the child of this function exceed the timeout, it's just cancelled. And in case of a with timeout, it throws an exception. We throw an exception. In case of a with timeout or null, we are returning null. Okay, let's move into the presentation or API layer. This is where our controllers, view models, and presenters live. So this is where everything starts. Because so far we used coroutines, okay, but we haven't really made them. I mean, we already had them because we're on suspending functions, and suspending functions need to be started on coroutines. But we need to start it somewhere. And again, in many cases, we don't need to think about that because the library will handle that for us. When we use a suspend modifier in here, it does not mean you are creating a coroutine. It means that this function requires a coroutine. And that is why Spring will understand that and create a coroutine for you. Okay? Minor difference, but it's not you who are creating coroutine, it is Spring that is creating a coroutine for you under the hood. In other cases, we need to start coroutines ourselves. We typically started with lunch, with coroutine builders. So this part of the graph. This graph represents how our programs looks like. So I can guarantee to you that once you get used to coroutines, this will make a lot of sense for you, because this basically shows the relationship between different kinds of elements in coroutines. So basically, in coroutines, we need to create a coroutine. We typically start with a lunch, but coroutines, to be created, needs to have a scope. So what is a scope? It's basically an object that builds a relationship between coroutines and also keeps some data, some configuration about coroutines. So every coroutine builder needs to be started on some scope. Scope is created by coroutine builders or by coroutine scope functions. So they are often started one on another. That's also why we need this with context when we are in a suspending function. But when we are not inside that, we need to start it, and we start it by creating our own scope objects. And this is how typically our programs start. We create a scope, then we launch a coroutine. On this coroutine, we call some suspending functions, and then we need to start another coroutine. So what do? We use a scope function like coroutine scope, and we can create a builder like async or launch, and call some suspending functions. This is how our program looks like. I hope it will get clear once you will have some more experience with coroutines. I will not talk about run blocking or run test yet, because we avoid using them on a production code. So how do we create this scope? On Android, pretty often, we just use a vModel scope or lifecycle scope that are given to us by library. But on other places, and on Backend, on task managers, on schedulers, on cron jobs, whatever, you often need to create your own scope. And how do we create a scope? So the first thing about scope, the first thing that we add to the scope, we create a scope, the coroutine scope function. The first thing we typically and nearly always, I think always add, is a supervisor job. As I told you, supervisor job does not care about its children, so supervisor job makes an independence between the children, so that if you do not set it, then all the coroutines started on this scope where one of them has exception and cancels all the others. We typically don't want that. When we create a scope, we add supervisor job so that independently started coroutines will be treated as independent coroutines in terms of exception handling. The second thing we often add is some kind of a dispatcher. I heard a really nice sentence today that the dispatcher's default is not the default dispatcher. I mean, when you call a coroutine on a scope, it is by default taking the dispatcher from its parent, and it's nearly always taking a dispatcher from its parent. And so it's quite rare a situation when you actually implicitly use a dispatcher's default. So it's nice to, in general, it's nice to set it, unless you want to set something else. On some projects, I've seen people creating your own pool of threads and transforming them into dispatchers. It's pretty easy. You can use dispatchers main on Android. We typically use dispatchers main because that's the most common need for us. And setting dispatcher. The next thing that we might do with this scope is we might cancel that. So Kotlin coroutines have cancellation mechanism. When you cancel the parent, it cancels children, so cancellation propagates down. And we very often use this scope object to cancel only children in some situation. It's of course very important on Android. On Android, you often enter some screen and immediately go to another one. And what happens? The tasks started by the previous screen. They should be cancelled because otherwise they are, wasting your resources trying to update views that do not exist, so making crashes and stuff. So cancellation very important in Android. this mechanism is very, very useful. Notice I can cancel a scope that cancels children's and also this scope, but it is considered safer to cancel its children's. Then the scope is still alive, so that in some cases it might be reused in the future. If you are not sure if it will or will not be reused, it's better to cancel children. Keeping an empty scope is no cost at all. And the last thing that we might set up on our scope, that is a form of a configuration for coroutines, is that we might set up some exception handler. So the default behavior that we are overriding in here is just printing an exception. That's the default behavior that we can override in here. And what do we do instead? We might send this exception to some aggregate. We might show some dialogue generically. We might do some generic mechanism for exception handling. Different things people do. Some people do not do anything and do not like doing anything with that. It's up to you. There is a mechanism that you can override the logging into some other behavior. Okay, so we have a scope. On this scope, we can start coroutines. About constructing a scope, there is also a published chapter. So on backend, on Spring, it often looks like that. So you define a bin with a dispatcher, with an exception handler, and you create a scope. That should be clear for backend developers. It's probably not for Android developers here. And then you just inject it, and you can use it to launch your coroutines. Tell me, are those coroutines started all at the same time? I mean, this sending happens all at the same time, or one after another? All at the same time, yeah. So we are starting multiple coroutines. It's like starting multiple threads, but much lighter. And that's how it looks like. That's also how it looks like on some work managers on Android. In Android, there used to be this convention that we set up our scopes on some base view model and configure that. You can find it on some projects still. I mean, often it makes sense because we are adding some additional configuration. But we have this view model scope that is provided to us by KTX, very popular and very often used by default. So if you need no specific configuration, just use this one and it has most of what you might need. Okay, the last short section is about testing Kotlin coroutines. So basically the first problem that when you have a function, like this one, this function is just fetching some data and producing an object out of them. If you want to test it, if you want to test the result of this function, this test might look exactly like a regular test, So you set up some mocks or fakes, you call your function under test, and you verify the result. That's exactly the same how it would look like if it were a blocking call. You just need to wrap it with run blocking. So time to mention this run blocking or run test. So the idea behind run blocking is that run blocking is a very special function that starts a coroutine, but it also blocks a thread it has been started on until this coroutine is finished. Okay? So it starts a coroutine, nice, useful, but blocking thread, in general, no good, okay? Except for some cases where you explicitly want to block a thread, you should not use run blocking. People overuse it vastly, okay? Sometimes it's needed. If you need for some synchronization reasons or for some library reasons, I had this case where I needed to block a thread to show the library that was measuring time of functions that this function is still going on. This is an explicit usage of run blocking and conscious usage of run blocking. But outside of these cases, it's blocking thread, and in general, blocking thread is not what we should do. But there are two cases where it is really needed. The first one is unit testing, okay? Because imagine that you start a coroutine in here, and your test will finish before your coroutine would even start. You just start a coroutine, go next, it's the end, so everything is fine. Why it's not? So round blocking is needed for these kind of cases, and it's also used to wrap a main function for the same reason, to keep your program alive until everything is finished. Okay? So the simplest cases when you just need to test the outer behavior, just wrap your functions with round blocking and it looks like a blocking call. Simple case, okay? Vast majority of the tests I've seen on the real-life projects. One thing to mention, this is often wrapped in some outer function like test or something like that, so that it can be replaced with something else in the future. You will see soon why. Another example, this is more like an end-to-end test, but you can also see it's wrapped with round blocking, and it's setting up a situation. There is a user. It's making some call, simulating some call, and then it's verifying the result. A typical test on some of the backend systems I worked on. And that's fine. 90-something% of tests, that's perfectly fine. But the fun starts when you want to test something that I call time dependencies. So take a look at those two functions. So the first one gets profile and gets friends, and produces a user out of them. The second one does exactly the same, but asynchronously. Okay? So what's the difference? So from the external behavior, there is no difference. Okay? The result is the same. Cancellation is the same. Exception handling is the same. Everything is the same. It is designed to be the same. The only difference is that when get profile takes X and get friends takes Y, like for instance 90 years, the first function should take X plus Y, the second function should take the bigger of X and Y. Yeah? So unless those functions take some time, you cannot see any difference. It's impossible. Okay? But if you make them take some time, then your tests are slow. And I worked for applications where there were tens of thousands of tests, and having a test that take 1 second, tests that take 1 second, would be very, very unpleasant for developers. And this is where the idea of a simulated time comes into play. I spend a lot of time in this chapter about that, but the idea is very simple. It's you're just using this run test or test scope or the test dispatcher, and when you do that, then everything inside runs on the simulated time. So when those functions, let's say that this fake delayed user data repository, it uses delay inside. But when it uses delay inside, it's not waiting a real time, it's just pushing the virtual time, okay? And this is very well implemented, so if things are async, it is simulated in this way, etc., etc. So if you do that, if you use run test instead of run blocking, if you change your mocks or fakes, you could use mocks as well, so that they have extra delay. Let's assume they each have 1 second delay. Then you can verify that the result and the time of that is 2 seconds, and the time of the second one is 1 second. Precisely, because it's a simulated time. So, the regular operations do not push that. It's a simulated time, so it's only pushed by itself. And that's everything I had for you. The book is finally published, and this is my announcement because it's the first conference when I am in where it's already published on Amazon. So I hope you will find it useful. And like always, slides will be soon published on the Twitter. Thank you for your attention and have a happy coroutines.
We still have time for any questions.
Yes,
Because you have books to give away, right?
Perfect. So, questions?
First of all, thank you for your presentation. And my question is, do we have some alternatives to thread local in coroutine scope? Do you understand what I mean? No? Well, because when we are working with in a single thread paradigm, we can put our variable to some thread local and be sure that, well, I'm talking as a backend developer, so back in time, we had like one thread user session, so from request till response. And having thread locals was pretty useful when you have to get some memory storage there. So, because coroutines can be run in different, the same coroutine, as I understand, can be run in different threads, it's not possible to use this. And to is it some mechanism to keep one value for all the scope? To not using it as a parameter of methods or whatever.
Thank you for staying, but I think we solve those problems a bit differently, so that there are synchronization mechanisms. We treat threads a bit differently. There are ways that there are cases where we, quite often cases where we synchronize accessing a state by using a dispatcher that is limited to a single thread. But the trick is that it's often not the same thread, because if you use a dispatcher IO limited parallelism 1, that's the dispatcher that will have only one thread at a time. But you never know what thread is that, because all the dispatchers, except for main, all the dispatchers are using the same pool of threads. That's very important because they are reusing the same resources. So there is this unlimited pool of threads that everyone is using, and it's when we need more threads, it's creating more threads. When they are not used for some time, it's removing them. But all the other dispatchers have their own limits to use those threads at one time. So default as many threads as you have cores, IO, 64, etc. But you never know which threads they will be using. So no, we do not use threads like that. I think your case could be solved with some kind of a custom context, but it's hard to talk about that because it sounds like a very bad idea to me.
Oh, okay, thank you.
And one more question before we go into the break.
Oh, I need two more questions.
You need two more questions?
Yeah, if you want to go, just go, don't worry.
Well, people that need a break, decide for yourself, of course.
Yeah, thanks for the talk. My question is, do you have any suggestions or best practices for synchronization on shared resources for the coroutines? For example, reading a really large file with multiple coroutines or whatever. Like any example where we want to share the resources. Thank you.
Okay, so I think it will not be a satisfying answer, because one thing is, of course, if you want to secure some resource, the trick with one thread is very popular. You can also use other things like mutex. You can also use a synchronization block, but it's not a good idea on coroutines because it's blocking when it's waiting and you do not know what it's blocking. And also it's not supporting suspending functions, so you can nearly forget about synchronization on coroutines. But nevertheless, do I have some ideas for more complex models for accessing more complex objects, like multi-file that we need to access by multiple threads. No, I have a friend who told me he implemented a very tough synchronization using mutexes that are supported with coroutines, but it's quite tough to use them, and that's the best I can tell you.
So just one thread.
I mean, one thread is an answer that no conflicts, yeah. But if you want to have a file that you want to read concurrently, then you need a more advanced model. And I'm not an expert on that, but there are ways to do that, and some forms of separation and separate locking. But well, not my field. Sorry.
All right, thanks.
One more.
Yep, we have one more question over here in the audience.
Okay. Hi. So I had a question because you said that, basically you only use run blocking for a couple of reasons, right? So for if it's your main method, or if it's some library that needs it, or if it's a unit test. But in that last case, like, is it the reason we use run blocking there? Is it just because JUnit expects it? Because is there an actual reason why it should be there? Because if, I imagine that if there's a test framework that uses coroutines or something, then you might not need it, right?
Yes, and that's right. So there are ideas, and I believe on some platforms it's already supported. I've never used that. I believe that there definitely are plans. I'm not sure what's the status of that, to make suspending function, and then you don't need run blocking. I mean, it's not that you do not need. You satisfy one need, that is that you can call a suspending function. You do not create a scope, but then you can use some coroutine scope or something else, and that's satisfactory. So yes, and the same with main. So actually, we started avoiding run blocking around main, because run blocking has some mechanisms that are not very good. Concretely, run blocking is setting up a dispatcher, what is quite tricky. You probably don't know that. I didn't know that. I also didn't know about it until I was debugging a code that was not working as it should, because someone used run blocking and then used concurrent things, and these things were not working correctly, and we didn't know why. And it turned out that everything runs on a single thread, and the cancellation could not happen because the thread was used by other coroutine. And then we figure out, hey, run blocking is setting a dispatcher with the thread that run blocking has been started on. This is one of the things that are tricky about run blocking. So they introduced suspend main. That is also not enough, because except for suspend function, we also need a scope. So we first use suspend main, then equals coroutine scope, what is way longer, but it's generally considered safer. It's less tricky in different ways, and I think it's generally considered preferable in modern programs. Thank you, and thank you again, and hope to see you on the next occasion. You can grab me on the corridor.